Hello everyone! I'm so excited to share with you one of the wildest, most mind-bending ideas in modern science: time crystals. I can already hear you thinking, crystals, okay, but time crystals? What's that all about? Let's start with something familiar. You've all seen regular crystals. Think salt, quartz, or diamonds. These are materials where atoms are arranged in a repeating pattern in space, like a perfectly organized grid. Now, time crystals? They're a whole different beast. They have a repeating pattern in time. Picture a system that oscillates back and forth, tick-tock, forever, without any external energy pushing it along. It's like a pendulum that never slows down, or a heartbeat that never fades. This sounds impossible, right? For centuries, physicists assumed it was. But in 2012, Nobel laureate Frank Wilczek dared to dream up this concept. And just a few years later, scientists made it real in the lab. These time crystals are tiny, fragile, and exist only under very specific conditions, but they're a game changer. They break something called time translation symmetry, a fundamental rule in physics that says the laws of the universe shouldn't care when you start the clock. Breaking that symmetry is a big deal. It's like finding a crack in the foundation of how we understand reality. Why time crystals matter. So, why should you care? Because time crystals could transform our world. Imagine quantum computers that store information perfectly, forever, without glitches. Or sensors so sensitive they could pick up the faintest ripples of gravitational waves from across the universe. Time crystals might even help us unravel one of the biggest mysteries of all. What is time, really? But here's the problem. Right now, time crystals are like rare, exotic flowers, stunning but so delicate they can barely survive. They exist only on a microscopic scale, and the tiniest disturbance, like a breath of air or a stray photon, can throw them off. That's where we come in with a bold idea. What if we could protect these fragile time crystals by embedding them inside larger, sturdier crystal structures? The big idea: a crystal shield. Think of it like this. Imagine a delicate ship inside a bottle, or a flower perfectly preserved in amber. The larger crystal becomes a shield, a fortress that keeps the time crystal safe from the chaos of the outside world. This isn't just a cool trick, it could make time crystals practical, bringing them out of the lab and into our lives. How do we do it? First, we need the right material for the outer crystal. It has to be tough, stable, and quiet on the atomic level, meaning its atoms don't jiggle around too much, which could mess with the time crystal's quantum magic. Diamond is a top contender. It's not just beautiful, it's incredibly rigid and has low phonon activity, which is science speak for its atoms stay calm. Another option is silicon carbide, a material already used in quantum tech experiments. Building the fortress. Now, embedding a time crystal isn't as simple as gluing it into place. We're talking about quantum systems here, so we need precision on the level of individual atoms. Scientists could use techniques like atomic layer deposition or molecular beam epitaxy, fancy terms for building crystals layer by layer, atom by atom, like stacking the world's tiniest Lego bricks. The goal? Wrap the time crystal in its protective shell without popping its delicate quantum bubble. Of course, this isn't easy. The biggest challenge is making sure the embedding process doesn't disrupt the time crystal's oscillations. It's like trying to wrap a soap bubble in tissue paper without breaking it. But with the right materials and careful engineering, we think it's possible. A glimpse of the future. So what could this mean for us? Picture a world where quantum computers are as common as smartphones, powered by stabilized time crystals that hold quantum information indefinitely. Imagine sensors so precise they could detect diseases at their earliest stages, or map the universe's gravitational waves like a cosmic symphony. This isn't just about tech, it's about understanding our place in the cosmos. And here's the bigger picture. Stabilizing time crystals could give us a new way to explore time itself. Why does time only move forward? What happens to time at the quantum level? These are questions that have puzzled philosophers and scientists for centuries, and time crystals might just hand us a new set of tools to find the answers. Where we stand. Now, I've got to be honest, this is still a theoretical idea. We've created time crystals, yes, and we have the techniques to embed them, but we haven't put it all together yet. Still, the potential is too incredible to ignore. The pieces are on the table, waiting for us to assemble them. I want you to imagine a future where time crystals are as everyday as the silicon chips in your phone. A future where we've harnessed the strangeness of quantum mechanics, not just to build better gadgets, but to deepen our connection to the universe, and maybe even to time itself. Thank you for joining me on this journey. I'm John L. McGarry. Let's keep dreaming about what's possible.